Today's lesson is on exponent laws. We're going to be learning about several different types of exponent laws over the next few days. So this is lesson 5, and exponent laws are something that you're going to need all the way until grade 12. So it's important that we are able to recognize them and recognize when we can use them. So our objective for today is that students will be able to demonstrate an understanding of operations on powers with integral basis. So that just means a number, a positive or negative whole number, and then a whole number exponent. So we're going to be able to generalize some rules about exponents after today. So here's lesson 5, exponent laws. Make sure you write down the title. I'm going to give you a second to write out the table if you need to. And then we're going to do the first couple together. So the first one, we have a column that says product of powers. Now product is just a special way of saying multiplying. So we're talking about multiplying powers. So notice here we have 5 to the power of 3 times 5 to the power of 2. So I can write that out as repeated multiplication, where I have 5 times 5 times 5. Remember, it's the base times itself 3 times, and then 5 times 2. So now if I want to write it as a product as a power, I can write it as 5 to the power, and I'm going to go back and count how many 5s I have. So I have 1, 2, 3, 4, 5 in total, so I can simplify it to 5 to the power of 5. Okay, the next one, I have 2 to the power of 4. 1, 2, 3, 4 times 2 to the 3. 1, 2, 3. So in total, if I go through and I count those up, I now have 1, 2, 3, 4, 5, 6, 7 2. So I can write it as 2 to the power of 7. Go ahead and complete the next 2 columns and pause the video. Okay, so there's the table completed. So now you have to see if there are any patterns in the table. And then it says use your patterns to answer the following question. So keep this table in mind as we look at the next question. It says what is the exponent law for product of powers? And remember, product means multiplying. Keep the base the same and add the exponents, keep the base the same and multiply the exponents, keep the base the same and add the exponents, or multiply the bases and multiply the exponents. So you can see in every example, the base stayed the same. So right away I can cross off C and D, and then we added the exponents. So the correct answer here is A. Please write down this law in your notes. All right, a little bit of prior knowledge. How do we simplify 6 over 9? So I'm going to write it as a fraction, 6 over 9. You need to be able to recognize what both of those numbers are divisible by. Both of those numbers are divisible by 3. So I can actually write 6 as 3 times 2. And I can write 9 as 3 times 3. And now that I have a 3 on both the top and the bottom, I can cancel those out, and I'm actually going to be left with 2 over 3. So we're going to be using this for our next power law. If you have something the same on the top and the bottom, you are able to cancel them out. All right, make sure you take a moment and copy it down if you need to. So this is the quotient of powers, the law of quotient of powers. Quotient means division. So last slide we were talking about multiplication. This slide we're talking about division. So the first one's already started for us. We have 5 to the power of 3 divided by 5 to the power of 2. So then there are 3 5s on the top of my fraction and 2 5s on the bottom. Now remember, fraction is just a fancy way of writing division. So now I can simplify using the method that we just wrote down on the previous page by canceling off 5s. I'm left with just 1 5 on the top, so my quotient is 5 to the power of 1. The next one, I have 2 times 2 times 2 times 2 on the top, and 2 times 2 times 2 on the bottom. I'll then cancel what I can, 1, 2 here, 1, 2 here, 1, 2 here, and I'm left with 2 to the power of 1. Next one, I have 3 to the power of 5, 1, 2, 3, 4, 5, over 3 to the 3, 1, 2, 3. Cancel off what I can. I can cancel off 3 on the top and 3 on the bottom, and I'm left with 2 3s. So that's 3 to the power of 2. All right, so the last one you can do on your own, and we're going to see once again if we can find a pattern. So what is the exponent law for the quotient of powers? So the division of powers. Keep the base the same and divide the exponents. Keep the base the same and subtract the exponents. Divide the bases, divide the exponents. Divide the bases and subtract the exponents. So in every example, we had the base being the same. So right away I can again cancel off C and D, and then I notice that when I do it, I actually am going to be subtracting the exponents. So once again, write that down. My rules are product law. If the bases are the same, I can keep the base and add the exponents. For quotient law, if the bases are the same, I keep the base and subtract the exponent. This will help us simplify complicated questions. So now that we have our rules, let's apply them to some examples. Write each expression as a single power using the shortcuts you've just discovered. So I have 4 to the power of 10 times 4 to the 2. First thing I need to notice is that my base of my exponent is the same. By base, I mean the 4. They can't be different numbers if you want to use exponent laws. Next thing I notice is that we're multiplying. So multiplying means I'm going to use my product law, which says keep the base the same and add the exponents. 4 to the power of 12. All right, next one, I look to check to make sure my bases are the same. Both of them have the base of -7. Then I check to see what operation I'm doing. In this case, it's division. So I'm going to use my quotient law. Quotient law says I keep the base the same and subtract the exponents. -7 in brackets to the power of 2. Don't forget the brackets. If you don't have the brackets in, your answer is wrong. All right, now I get to include a couple more. I'm going to focus on the first one first. So I'm going to focus on 3 to the power of 7 times 3 to the 2 first. I notice that that is multiplication, which means I can add the exponents. 7 plus 2 is 9. And then I'm keeping that last step the same. This is division, which means I keep the base the same and subtract the exponents for a final answer of 3 to the power of 6. All right, next one. My bases are the same, which means I can start with my first step It's division, which means that I subtract the exponents. 12 minus 5 is 7. And then write out my last step. And since this is multiplication, I can now add the exponents. 7 plus 3 is 10. So my final answer is negative 1 to the power of 10. All right, we're doing good. Now we just need to see, well, what happens if we have variables? Does that change anything? So variables work exactly the same way as an integer does. If I have a variable, it just represents an integer, but I can still use exponent laws as long as the bases are the same. So for example, I have a to the power of 3, bracket a to the power of 2. The bracket indicates multiplication. So I can put a little dot in there if I need to. And the base stays the same, and we add the exponent. Okay, next one, we're dealing with division. The base is b, and then we subtract the exponent using our exponent laws. All right, a couple different steps now. Use your product law, y to the power of 5 plus 3, which is 8, and then divide it by y to the power of 6. Now I can use my quotient law. Y to the power of 8 minus 6 is 2. So that's my final answer when it tells you to write it as a single power. So go ahead and try the next one, and I will put the answer up. Wait a second, what's the exponent on the second term here? Negative d doesn't have an exponent. So now you can look over at the wall and remember that any number, including exponents, you can always put an invisible 1 on there. So if it doesn't have an exponent, you need to add in the 1. Do not put a 0 or you will get the wrong answer. So this becomes negative d to the power of 1, 2 minus 1, times negative d to the power of 8. Now we use exponent laws, negative d to the power of 9. All right, next one. What about 2 to the power of 2 times 3 to the power of 3? Can I simplify this using exponent laws? The answer is no. I can't simplify these using exponent laws because I have two different bases. In order to use exponent laws, you have to have the same base. All right, so let's try some trickier ones. Can anyone simplify this expression? We have x to the power of 2 times y to the power of 5 times x to the power of 3 times y to the power of 2. So remember, only things with the same base can be simplified. So my x's have the same base and my y's have the same base. So when I simplify this, I'm going to use exponent laws on my x's separately and then use exponent laws on my y. So I have x to the power of 2 plus 3, which is 5. I can leave it in brackets if I want, times y to the power of 5 plus 2, which is 7. So that's as simplified as it gets. Because they have different bases, I cannot add the exponents here. So that would be my final answer. Okay, evaluate the following expressions. Simplify first using the exponent laws. You can use your calculator at the end to check. All right, 7 to the power of 2 plus 7 to the power of 3 times 7 to the power of 2. So I see bed mass. I think, okay, I need to do brackets first, but inside my brackets, I just have 7 to the power of 3 and 7 to the power of 2. I'm going to skip the brackets portion because there's still an individual number with an exponent in it. You could figure out what 7 to the power of 3 is and 7 to the power of 2 is and then multiply them. However, instead, we are going to use exponent laws. So I'm going to multiply those. 7 to the power of 2 plus 7 to the power of 5. Bases are the same, which means I can add the exponents. Now, my product rule and quotient rule are for multiplying and timesing. There is no rule for addition. So if you see an addition sign, just think BEDMAS. I need to do BEDMAS, which means that I will square my 7 first. 7 squared is 7 times 7, which is 49. And 7 to the power of 5, use your calculator to help you out on that one, 1,600, 807. Or sorry, 16,807. Now I can add those two together. I get an answer of 16856. All right. Next one. Let's try and figure out what's going on here. I see a couple sets of brackets. I see square brackets and I see more round brackets. So most of the brackets that I see are the square brackets, so I'm going to deal with those first. So that's going to be my first step. I'm going to simplify what's inside of it using the exponent laws. So my negative 10 stays the same out front, and then I look inside my brackets and say, okay, I'm dividing, which means that I can subtract the exponents. So 6 minus 4 is 2. Okay, I know I have a lot of brackets going on here, but now I just technically have one number in that set of brackets, so I can use my exponent laws to simplify here. Don't forget about your invisible 1 on the negative 10. So I now have negative 10 to the power of 3. 1 plus 2 equals 3 minus 10 to the 7. So at this point, I'm finished with exponent laws, and I need to solve. So negative 10 to the power of 3 minus 10 to the power of 7. My answer is going to be negative 1, 2, 3 zeros, 1, 0, 0, 0. Oh, that's a big number. 10,001,000. Negative 10,001,000. All right, last one here to try on your own, and then we can do some practice. All right, here is the answer, negative 16,400. I just want to go through the solution briefly because something a little interesting happened here. Main thing I noticed right away, I did my exponent laws inside the brackets. That was fine. But then when I got to this step here, I said, whoa, 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 do these have the same bases? And the answer is yes, because remember that negative sign right at the beginning? It's actually hanging out front. It's not directly attached to the exponent. So I leave it hanging out front, and I can still apply my exponent laws. All right, lesson's over.